Hello.
Hey. Are the codes just to keep the door propped open? Or?
Yeah, the door stop doesn't work. No.
Oh.
This side.
I was like, it looks like it goes. Okay.
Yeah.
Just, can you just hold it up further?
Yeah, that might be better.
There we go. That was just slides up. Oh. I have, yeah, question about the lab notebook.
Okay. I'm going to pull up the lab for this week.
Here.
Is this the momentum lab?
Yeah.
Or mechanical energy?
Click that one. Let me see it real quick. Yeah, that's all.
This one? Okay.
Yeah. Both of them has problems with it anyway.
Okay.
Probably have problems. Other one later. So, where's the top there? Okay, so, okay, this kind of makes sense to me. So I was just wondering, for the very first one, it says for the first experiment, explain what work done by the following methods independent of the path taken.
Mm-hmm.
What I was wondering was, to do the independent path taken, we put at an angle, you know? That's what we're supposed to do, right? Put it at an incline.
Mm-hmm.
Put this block in an incline. But as soon as you do that, don't you give this block potential energy as well? So then you just change the energy that gravity is imparting on the whole system and you messed it up. I think
That would be the work done by this block, not the work done by this block. This says explain why, not
then by the falling.
done by the falling mass. It's only the falling mass, so you have to consider that. And
Okay.
it says explain, not show.
So do we have to show any of our? Like, that's what the other thing I was kind of wondering too is, yeah, when it says explain, how much do you have to go into it? Like, for this, for example, I started on G because I can't the first one, I just go to the last one, that's how I do things.
Mm-hmm.
But it said what effect will the release point have? And do you have to show, because we did, in our experiment, is we did it at different release points.
Mm-hmm.
So, you know, this much. So that we actually did change the release point. So
Yeah.
should I include that in that question? I mean,
yeah.
Okay. Okay. But then I wasn't sure, like you said, like how much to do, like, this is explain why, then does it not show that it
Mm-hmm.
So.
I mean, if you have the data for it, it just backs up what you're saying.
Yeah. So just try and explain. Like, how long do you have for each one of these questions on average? Like a couple paragraphs?
A couple sentences.
Really?
I would say. Yeah.
Oh crap, probably.
I can check how much I wrote for that lab in particular if I have it. But
I'm just not sure. I think a bit.
It's typically, yeah, a couple sentences. Yeah.
Yeah.
Just a couple sentences for each thing. Yeah. And then calculations. But G got a paragraph, I guess. No, that's only 2 sentences.
Just literally.
It's literally 2 pages.
I've already written 2 paragraphs for G.
Yeah.
Oh my god.
Well, I mean,
I guess I should under engineer it rather than over it.
you explained it very well. That's a good thing.
Oh well, I guess I'll know to not use that much now. At least that'll save you time.
Yeah, you just have to write a book about it.
Oh well. Well, at least. Yeah, I'll fix it. I'll try it. I'll do that. I was just wondering. I always seem to have electric experiments usually. Or I suppose it's better.
Is that the only question you had?
I think that was the only one I had from that, because the other ones didn't seem, like the other ones I knew I could just use a few sentences for like, what did this system, or this spring do to the system, and that one was, there's not much to say other than what it did, so that one's kind of something there. The other one, I'm trying to remember now. None of them seemed very hard enough. They're all, because, yeah, B and G. B was that one. Well, write down the energy equation, that was the other one. I literally just wrote these next to it. D, I know the answer to that one. Can you ignore friction? I was wrote, because more than likely the data will never show that. Maybe I'll get lucky, but only one of my labs out of all of these has actually been small enough error to actually avoid friction. All the other ones just get totally messed up. So we'll see. Then deprivation of kinetic potential for 1 and 2. That was the other thing I had to ask. Were those kind of the same? Because if you wanted to explain your data how for to calculate friction, but for the other ones is, if you sum up your potential and you sum up your kinetic, they should be equal, obviously. Or, well, okay, the mechanical energy in this one at least should be the same. So you could sum up the initial mechanical and the ending mechanical, and they should be the same, but they probably won't be. So is that kind of part of the F?
Yes.
Okay. Ratio of the kinetic and potential. What do they mean by that actually, now that I think about it? Do they mean the beginning or the end? Because the ratio of the kinetic and potential will be changing throughout it's following.
Well, depending on how you define your system, you start out with all potential and end up with all kinetic. Right?
Okay, but we didn't. Well, this is the one where we did this.
Yeah, so that's on the
But, oh, I recorded something. Y initial, Y final. I just said the Y final was 0 though for simplicity's sake, So, because we can put the point wherever we want it to be. So that's why we can say the potential energy is just 0 at the end.
Yes.
Okay. So then that'll work, yeah.
Yeah.
We can actually, can you graph it then?
Yeah. Yeah, you graph change in kinetic versus change in potential.
I wish we could do that way.
I don't know why I did it up like that.
Oh, okay.
Should have taken it longer, so. Whatever.
Just wondering why.
Yeah. I probably won't go through the x-intercept. You wanted everything to go through the x-intercepts on all of our labs.
Oh, okay.
The urgent up there.
Gotcha. Okay, I see.
Zero.
Okay. I think I'll be good then.
Yeah.
I think I'll be able to finish this up just fine. So.
Yeah, it's a really straightforward lab. Mostly.
What's the next one like then? I didn't look ahead.
Next one.
Some momentum. That's
Yes.
one word.
I think it's collisions.
Ooh, yay.
Oh, it doesn't have a picture.
Oh.
Yeah, you have two gliders on a track, and you run one into the other.
Okay then. And then you.
Yeah, I think you have one stationary.
Okay,
Yeah.
that's easy enough. I've taken the
Yeah,
physics
sticky
in high
and
school, so
elastic.
I'm used to doing these. I especially remember these ones because my teacher would just let us pick whatever we wanted. He'd say like, "What do you want to be the stationary thing?" And that's the. So I remember for sticky collisions, we had the Dalai Lama on a crotch rocket slamming into a Yeti. That's what happens when you let students choose random crap. Like one person will just throw in each idea.
Mm-hmm.
I remember another time we had, what was it? Oh, for inelastic collisions, we had, I said a kitten, and then somebody else said Charles Manson. So we had Charles Manson slamming into a kitten.
Oh.
That was very interesting.
Yeah.
But yeah.
Yeah, you're just gonna have gliders, carts,
Okay.
track.
And then what are they? Is this the restitution?
Yes.
Okay.
Yeah.
I thought it was supposed to be. Oh, I saw. Professor Lauren wrote it as whatever this symbol is, like at the end.
Yeah. She changed
Or was
that.
it a-
In my notes from last year, she wrote an E, but this year she wrote it as an N. She might have decided that E was confusing. or
Because
something.
E is in Euler's numbers.
Yeah. So,
It was. What was it? She wrote it.
yeah. That's
Super fancy and I don't know, something like that.
It's super clever.
I don't know. Is there?
Yeah, I don't know the Greek alphabet. Except
I'll look
for,
it up
like,
when I
the-
have to throw it in my report and I'm scrolling through all the different little symbols, probably. But
Yeah, I think you
Is this
assume
one
that one of them's
inelastic or
elastic
elastic?
and one of them's inelastic. Use Velcro
Oh, okay.
and inelastic collision, and use rubber bands to simulate an elastic collision.
So the rubber bands hit. Okay.
Yeah. And you have to, I believe you calculate E. I don't remember. Oh yeah, you do. You use the E calculation for the coefficient of restitution.
Wait, is this not a Latin fork again? It's one of these?
Yeah, it's one of these. I think you have
Just 3?
2 in a row and then
2 in a row again.
Of Latin fork?
Yeah, I feel like this one is longer though. Yeah, it's
It's just been alternating, so I got so used to that. I was
Yeah.
on the very end of the side.
how many more labs are there? There's not many.
9 or 12.
Yeah, so there's
And then
circular momentum is a full ride up and torque
torque isn't?
No.
Oh, okay. And then angular is.
angular momentum isn't either. Oh wait, these are one of the ones where is yeah torque is a full ride up.
Oh, in your lab, right?
Yeah,
Okay,
it's
then.
in your lab ride up. Include those
So
questions.
there's 2.
Yeah.
What about circular motion? Is that one?
Yeah, that's a lab write up. So you have 2
Yeah.
of the worksheets and then 2 of the write ups.
Okay. Cool. Oh, well, not too bad. What are we? Angular momentum.
Yeah.
Okay, then. Not half bad. I'm just trying to remember what Ben through physics in high school. And I looked ahead in my book, but I don't remember now. Because I'm going to take the column of physics, 1 through 3, so I just decided to get the giant book. So I don't carry it anywhere because that is a backbreaker.
Yeah, I only got the first one, and then physics 2 didn't require a book at all.
What?
We used an online software, and we didn't have to read. We watched videos.
Okay then.
Yeah. Oh, it depends on the professor you have. There's gravitation left.
Well, just in case I have a giant
Yeah,
book
you'll be
now
able
for-
to use it to study.
for 3 semesters probably. And what?
Harmonic motion, spring,
Oh, okay.
and pendulums. We study at the very end.
Okay. Do you also do the dampening functions as well, or it look like on the harmonic motions in the back, it looks like the dampening function
Possibly.
right here.
Yes.
Dampening.
Yes, down there. Yeah, that's what it's called.
Okay. So did you just keep all of your notes from physics by chance or something, or?
Yeah, by chance. I have no clue why I kept these books, but they're in a pile on my desk.
Well, I guess it's useful at least.
Yeah.
I usually just throw most of my notes and stuff. Well, most of them, because where did I put them? I was just going to say, I kept all the notes that I had from calculus in high school, but where did I put those? I don't know where those went now. I should look for those again, because I thought I had bought them. Or maybe I threw them? I gotta look now. That's gonna annoy me now, because I want to know what those are. I didn't forget many things to bring to college, but I hope that wasn't one of them. Well, I haven't needed it, apparently.
Yeah. I don't know, for some reason I brought some of my textbooks home at the end of the summer. So there are textbooks spread between Arizona and Chicago.
Well, if you don't, yeah, if you want to keep them, my mom's a lawyer and she sells some of her old law school textbooks. I remember one of them was, I remember when we were little though, she didn't really care before we did it. So we were like, can we just have this one and like doodle it in random crap? But what we actually ended up doing was we cut the middle. It's such a thick book, we actually cut the middle out of it and had a secret little storage space inside in the book. It was one of those classic little things. You can just, it looked like a law book, and then you open it up and it's hollow. It was great because I just felt sneaky. Well, ingenious, because that and then. Oh, yeah. I had my laptop in there. My laptop's relatively heavy, so.
Yeah.
Like when I ordered my laptop, I just looked for like the specs of it. I didn't look at the weight or the size.
Oh, that was one of the main things I looked at for mine.
I didn't look at it at all. I really should have. I was like getting it. I'm like, oh, this is big.
Yeah.
Because it's big for a laptop. I mean, it's this thing right here.
Okay, yeah, that's pretty large. The junior high I went to had laptops that they gave out to students.
Oh, yeah.
The technical school.
Yeah, ours just started that.
They were gigantic and had an auxiliary battery that weighed as much as a laptop.
Oh,
so everyone's backpacks weighed half as much as they did.
Oh my gosh, that's terrible. Like we got these tiny little ACES books.
Oh, see, that's smart. They realized after a couple years that, giving gigantic laptops to junior hires was a terrible idea, and they all had back problems, so they switched to those.
Oh,
but not before they got all the students rolling backpacks to go with them, and it was a very small school, so like the hallways, like sidewalk width, and you have passing period, and everyone's got rolling backpack.
Oh my gosh.
Yeah.
That's terrible. Yeah, I think well, are you from around Chicago then, or I can't remember now?
I'm from Arizona.
Oh, yeah. So, wait, yeah, you said, okay.
Yeah.
But was it like a city school then, or was it more out in the country?
Well, it was suburb.
Okay.
Kind of further out suburb.
Okay. Because it's a pretty rural area where I'm from, so our school was relatively big.
Oh, well.
Like there weren't many people,
that was
but
like
just more space.
like prep school that you could. It was a public school, but so it was smaller. They only offered 8 classes, and if you got a C, you got kicked out.
Oh wow.
Yeah.
In the AP, I'm guessing.
No, that's all they offered.
Oh, with AP. Oh,
Okay,
gosh.
Virginia High is all honors, but in any
Wow.
class, and say then you have to go to a different public school. I transferred for high school because I wanted to take more than just AP classes,
Yeah.
like
Oh,
music
that
and
sounds.
art and all that stuff.
I went to a small enough school that we only had one AP class, but the thing was, is there was a college not too far away, so we took courses with them,
Mm-hmm.
which was basically we had our teachers teach college level courses, you know, and you get credit for it, except they're just
Dual enrollment?
yeah. Well, no, it wasn't dual enrollment technically. I'm not sure how they worked it out, but it wasn't technically dual enrollment is the thing.
Oh.
So I've never really quite figured out what the word was for it, but it was funny because it was like, you could tell it was easier than college courses, but you still got college credits, so it felt a little cheap at points, but other times it was relatively hard.
Yeah.
The best moment I do remember is one of my teachers. He was a very goofy teacher anyway, but he said that according to the rules, for the class, you know, because we had to follow the rules, because it's supposed to be a college class, of course, he had to hand out a quiz at the end of the semester, a final. So he literally handed out a quiz and then just took it back. It's like, I handed out a quiz at the end. They never said I had to grade it, and I was just like, oh my god. Like, admittedly, it was okay because he was a great teacher anyway, but it just felt so rough.
Yeah.
We probably learned just as much as maybe even more than some college classes though, because he was a great teacher.
Yeah.
It all depends on the teacher, really. Although he was goofy at the same time. He was one of those people who, he had a PowerPoint slide, but the reason he had that was because otherwise he would just go on tangents he could go off on tangents the entire class hour if he didn't have anybody to remind him of what the hell he was doing. That's what he is. He's one of those people that could talk for hours. That's how you can describe him. He could just talk and talk about random stuff, and it was great. But no, I only took one AP quiz ever, so.
Really?
And that was for the one AP course we had, which was AP English, wasn't literature, it was language, yeah. Yeah, we took the language quiz, and I thought I had done really bad, but it turns out I got a 4, so yay. Which, admittedly, I must have done really good at some of the part, because for the third essay, it was the first 2 essays, and I worked through all those, and I thought I did pretty good. Then they got to the third essay, and my mind just like died, and I literally got like 1.5 paragraphs. That's all I could think of, and I was like, I can't think of anything more, so I just stopped.
Wow.
Which is the worst feeling ever when you have like 15 minutes left and you just can't think, and you're like, I know I should do something.
Yeah.
Oh, that was stressful, but then I got a 4 anyway, so who cares?
That's good.
It's the same with my driver's test, actually. When I got my license, I thought I messed up, like, I don't want to say right off the bat, but relatively early in the test, and I didn't look ahead as to how they did any of the grading, whatever you'd say, the criteria for what passes, what doesn't. So I thought, I was like, oh crap, I probably failed. So I just went through the rest of it, and it turns out I passed anyway. But the entire time I was just like, I failed. It's interesting. It's one of those things where you look back on it and you just laugh, but at the moment it sucks and it's stressful. Beating myself up because I'm failed this. Completely messed everything up. But you didn't. But admittedly, probably wasn't like. I just always wonder how they do the driver's tests in like a city. Like if you just have to go in the city streets, because admittedly it was a city of 10,000 people that I took it in, but that's very small anyway. I mean, it's not like we went on that day or anything, so we could have, but we didn't. So, or wait, well, we did, but not on one of the busy parts, is what I mean. So
Yeah.
I just wonder how they do it, because it seems like it'd be terrifying to try and do it here. I'm just not used to it. I'm not used to any big city traffic of any kind. That's why I'm glad I don't have to drive. Oh my gosh. I'm used to a nice road with nobody on it that is straight as effing hell.
Mm-hmm.
Well, not in Minnesota, but I've driven in like North and South Dakota. Those are straight roads. Have you ever been to South Dakota or North Dakota? Oh. If you ever look up the interstates from specifically North Dakota, it's great because there's an interstate, and it's literally just like, North Dakota is basically a box anyway, and they literally just went straight through the middle. There's an interstate, that's the main highway, is that. There's just one solid shot straight through the middle of North Dakota. And oh gosh, it's terrible to drive on. It's bad. Because there's nothing to do, but it's better than too many people on the road. Like, the only way we figured out how to get here is you have to go through the south loop, and that's terrifying. The last 2 hours take the longest, and they're only like 30 miles. No, it's just bad. Oh well, in case anybody else shows up.
Alright, see ya.
See ya.
Okay.
Holiday party. Oh, holiday party.
What that class reaffirmed is that it's nice to be about community. Oh, yeah.